In this fossilized sea scorpion, we see a creature that grew to the size of a large dog. Paleontologists in Queensland have uncovered remains of spiders the size of house cats, massive millipedes, and dragonflies with the wingspan of a crow. It is easy to assume these monsters belonged to the age of the T-Rex and Triceratops, but carbon dating proves these giants lived hundreds of millions of years before the first dinosaur evolved. This timeline forces a question. How could insects possibly grow to the size of large mammals, and what eventually wiped them out? The answer has nothing to do with their genetics. Early Earth was powered by a volatile atmospheric engine, and its specific chemistry dictated exactly how large a body could grow. 600 million years ago, Penosia's land was a barren wasteland. Without a protective atmosphere, its surface was continuously bombarded by deadly UV radiation. To survive, early life was forced into the deep oceans. There, these organisms developed photosynthesis to harness energy from light. As these organisms multiplied, they released a massive chemical byproduct. Over millions of years, the oceans became supersaturated with oxygen gas. Oxygen is a lighter gas, so it bubbled up from the ocean and built up in the stratosphere. This formed the ozone layer. This invisible chemical shield allowed life to finally escape the predatory oceans and conquer dry land. 100-foot-tall fern trees colonized the empty continents, erupting across the landscape to form a dense global jungle with zero predators to eat them. But the ecosystem had a missing link. Bacteria had not yet evolved the ability to decompose solid wood. Look at this massive mountain of coal. When those prehistoric trees died, they simply piled up. Millions of years of intense pressure slowly baked those unrotted forests into the fossil fuels we extract today. Because these forests were pumping out oxygen and nothing was decomposing to consume it, global oxygen levels surged to 15% higher than they are today. This environment enabled a specific biological reaction. Insects lack lungs. They absorb air through skin pores called spiracles. Normally, this limits their size. But with the atmosphere saturated, dense oxygen pushed deeply into their spiracles, allowing their bodies to support much larger masses without suffocating. Millipedes the size of anacondas were the direct physical result of an Earth pumped full of hyperdense oxygen. The era of giants ended through massive tectonic shifts and continuous volcanic eruptions. Sulfur and carbon choked the sky, blocking the sun and killing the forests. Global oxygen levels plummeted. During the Permian mass extinction, 95% of life perished. The giant insects suffocated as the thinning air could no longer sustain their massive bodies. Only the tiny, highly adaptable insects that required minimal oxygen managed to survive the chokehold. Long periods of deep environmental stability build absolute giants. But when the atmospheric engine collapses, nature ruthlessly favors the absolutely small. We see the aftermath of this era in our modern industrial engine. Power plants are still burning the remains of those undecomposed prehistoric forests. The only remaining legacy of Earth's first rulers is the compressed coal currently being burned to power the very screen you are watching.